Okay, so Lua, it is easy to learn. Is it a scripting language? Nah, not really. It's not, Bash and it's not Perl. They're scripting languages. It's a programming language. It's got some cool things about it that are definitely programming oriented, I think. So it's not a scripting language, I'd say. Certainly, I think I described it last week as like Python minus, which is probably reasonable, but we'll see. And as we said last week, it's been used for all sorts of gaming, and it's probably, and again, its sort of biggest success would be Angry Birds written in components. So yeah. What else? So it's extensible using libraries. Well, that's the same as Python, right? Python on its own doesn't do too much. It's the libraries that count, like most things. So what else? Again, if you've done Python, you'd say, yep, I just need to know three things, really. How do you instantiate a variable? How do you do I/O? And what are the control structures? That's about it. And you're pretty good to go. Nonetheless, it's always good to know how some things actually work. All right. So and I guess the reason that this week is set up the way that it is because the unit doesn't have any prerequisites technically. What I reckon on that is that most of you should have done programming principles already, so you should be familiar with variables, data types, expression strings, and how to print stuff like that. So you just need to know how to do it in Lua. And most of the time, it's pretty similar to what you'd already know. But every now and again, there's a gotcha that's language specific, which is what you want to know about, really, I think. So, what else? Well, no surprises there. So, just don't. One thing I should point out too is that Lua is the language that Corona uses, but Lua is a language in its own right. So nothing stops you from running Lua on its own, should you wish to, independent of Corona. That may or may not be useful for you, I don't know. So you can definitely go to Corona. I've got it on this box actually at the moment, so we might do some things with that later on, but probably not today. Anyway, so that's why I was mentioning about things like thinking about, I think, testing environments for Lua. There's a few of them, but you might find that not all of them actually work with Corona particularly. So you've got to think about how you might want to manage that, either inside or outside of Corona, perhaps. Alrighty, yay. There's a well, you got to learn. That's what we should have done last week, right? Is hello world. So we now see how we do comments. We now know that main.lua is a file name something's going to look for, and we notice how to print something, how to get some output onto the console. Wow. But again, it's the first thing you do in any language, right? So no big deal. It's useful to know how it's going to interpret, how the parser is going to actually parse the statements, and that tells us pretty much exactly how it's going to work. You can add more than a statement on a line, which is useful. You can have things separated like so, and that it works pretty much the way you might expect, except that, of course, I suppose we're using a semicolon as a separator there, but a space in the first instance, which is a little bit more unusual compared to some languages, perhaps. Anyway, so variables, pretty straightforward, we will see, mostly. It is case sensitive though. That's a bit of a, and again, people that are used to languages that are case sensitive, no problem, you'll be right across that. People that aren't, that causes lots of interesting issues that aren't obvious necessarily sometimes. What else? Well, so we can print the name of a variable that prints 10, which is what you'd expect it to do. Although, of course, unlike a language like C, we need a format specifier. You don't have to have one in Lua particularly. And I guess just thinking about variables, as we said, you can't use reserved words like most languages, and so there's some obviously reserved words there to do with control statements and other sorts of things you would use in a language. And there's some sort of conventional and one unconventional idea of potential variable names. Let's see. And having underscore as a variable name is kind of interesting, but you can do that if you want to. but we try and choose names that make sense. And again, the names you choose will be aligned to your coding standard, whichever one you pick, right? So it should be fairly straightforward. Like other languages, values, and obviously variables have types. So clearly 10 was a number. And they're the types that Lua has. We'll particularly use those types, but nothing stops you from using threads if you want to. That might be helpful for the problem you end up solving in your assignment. It depends. Let's see. Some obvious types. There's a nil type. So yeah, you can test things that haven't been initialized, which is sometimes useful. It's not the same as 0 though. Okay. Let's see. Boolean type, fairly obvious, I would think. So no surprises there. And generally Lua does what you expect when it evaluates logical expressions, but we'll come to that. Yeah, numbers are numbers. Probably the most important thing is that numbers are automatically real numbers, or strictly speaking, they're double precision floating points, which means they go up to, is it 1e to the 308th? I think from memory, is that an IEEE double? Something like that. It's pretty large, large enough to hold most things. Okay, so the fact that Lua decides that things are already floats is sort of useful when used to other languages that don't make those assumptions. So that's pretty cool. C, for example, doesn't do that. C definitely differentiates between things like integer division and floating point division. If you get the two mixed up, strange things happen in your program. Whereas Lua is pretty forgiving about stuff like that. I think everything's automatically a float. Anyway, so strings are what you expect, and there are some conventional looking strings, I suppose. What else? We'll do some function things next week to say, we can do some cool things. Like you can do functions in Python, you can do functions in Lua. And functions can return more than one value of different types, which is sort of useful too. So, much like Python. So that's kind of useful sometimes. Tables are arrays, but they're not. Well, they are. I guess I'd say if I thought what a table, it's an array, so it's useful. And the keys don't have to be integers. They conventionally are. They don't have to be. So that's also a useful thing. And again, you're going to find some of the things we look at in Lua, you'd say, that's a bit of a strange way to do something. But every language has got its strange ways of doing things, okay, given the science that it's based on, okay. So, Python's based on lambda calculus and lambda expressions, so it does things a certain way that other languages don't. JavaScript does things in really strange ways sometimes because that's how it is. So, yeah, but some things are hard to understand why it does things in particular ways. Oh, there's some table examples, just to show you that the keys don't have to be numeric, I suppose. There you go. So they're assigning something with a non-numeric key, because you can do that if you want to. So by convention, you tend to use the square brackets, like many other languages. But you don't have to. You can use dots instead. Yeah, that's interesting little gotcha there, which is sometimes fun. I already mentioned the integers as keys thing. That's pretty straightforward. You tend to use ints as keys, but you don't have to. And in Lua, you can leave, as it says, you can leave holes. You don't have to have things necessarily sequentially allocated. When it says it causes confusion, it doesn't change where they are, but it makes a difference in terms of when you want to define the size, just to find out how many elements are in the array. If you start putting holes in it, it doesn't know about the holes, and so you get the wrong answer. That's what it means by confusion. Okay? It's not that the language is confused. It's just that it lets you allocate things willy-nilly if you want to, but it won't give you the correct answer for a number of elements. It might do that, actually. I won't do it today, but it might actually fire up Lua and show you that, just to prove that it does do that. Okay. Expressions are pretty conventional, I guess. Use all sorts of operators, except I suppose for negation, let's see. I guess that we use the tilde instead of a exclamation mark, I suppose. But otherwise, things pretty much evaluate the way you expect it to in one particular case. And otherwise, things work the way most of the way you expect. So there we are, doing some addition. It does what you'd expect it to do with no surprises. And the same thing with most other operators, except in one particular circumstance, which I'll explain in a sec. So, again, for people that have used any language at all, whether Python or anything else, you'd be saying, yep, that makes perfect sense. I know that the addition's a binary operator. That's no surprise. I can work with that. And, subtraction works the same way, as does most other things. So, division, I just skipped over multiplication. How dare I do that? Does what you'd expect. Well, division, yeah, I did mention that because everything's a float automatically, so I suppose if that was C, it would evaluate a bit differently, right? So as I mentioned, C uses integer division and floating point division differently. So let's see, 1 divided by 2 in Lua would be half, would be 0.5. 1 divided by 2 in C would be 0, because it'd be integers, right? So we'd say, so you don't have that gotcha to worry about, which is probably useful. Mod function works the way you expect. Exponentiation does almost. So I know some languages use a double asterisk, some use a little caret symbol. This uses the caret symbol, which is fine. There is a little gotcha about this, but it's about order evaluation more than about actually doing it. So, and again, no surprises for you guys, I should expect. Negation works the way you expect. And what doesn't work the way you expect? When it says high school maths, what's the rule you guys would have used? BIMDAS, right? Works like BIMDAS, except in one particular case, which is to do with exponentiation, which I think I mentioned somewhere, or maybe I didn't, just to make things difficult. I thought I did mention it somewhere. Maybe I didn't. No, I did actually. It's coming up. Okay. Yeah. You've got to watch out for that one little thing. It is BIMDAS, except when you've got exponentiation together, 2 in a row. It's not left to right. All right. So, following BIMDAS thing, you know exactly how that would work. What else? So the precedence rules work the way you expect BIMDAS style, except with double when you've got exponentiation in the same together, basically bound together. Then it goes right to left, not left to right, which is a bit bizarre. But otherwise, things work, I guess, BIMDAS style. What else is? Otherwise, that's fairly normal. What else? Usual sorts of operators there. And then we are using the tilde for not, okay, as I think I mentioned. And using double equals for equals is common for many languages as well. So 1 equals for assignment, 2 for equality, fairly standard sort of stuff, I think. What else? True and false. Okay. So is that doing what you expect? Yeah, x is less than y. It's false. Well, it's not true, is it? That's probably okay. Yeah, that's right. Okay. Yeah, okay. True enough. All part of the fun. The fun comes when we start doing logical operators. Again, the usual sorts of things. I did say nil wasn't 0, but nil and false could be false. Nil can be false, which is useful sometimes. Okay. But again, conventional sorts of things. So does this work the way we think? False and true should be false. That makes sense. True and true should be true. 5 and true would be true because and returns its first operand if it's false. Otherwise, the second. That makes sense. It's shorthand evaluation, right? That makes perfect sense to do that. 5 and 4 returns 4 because 5 is true, so it should return 4. And nil and 4 returns nil because nil is equivalent to false, and so it should return false, not 4. That works. it makes sort of sense in a bit pattern logical way, in that sort of way to think about it too. Oh, that's kind of clever. Yeah, and it all does sort of the reverse. First operand if it's not false, otherwise returns the second. Always good to test these things. I won't do it right now. We might test it maybe next week and prove these things actually evaluate the way that we say they do. It's always good to know. What else? Oh, we should do something about coercion to different values. That's always good to know about in another language. That does what you'd expect it to do. If nil effectively is false, then not nil must be true, and obviously not false is true, and not 0 is false. Worth remembering that one. Concatenating strings together. Okay, so that seems to work. The first one's 2 strings, and then the second one. So wait a minute, they're numbers 0 and 1. So Lewis looked at that and said, yeah, but you're using a string concatenation operator, so you want me to treat them as strings. So what that really is the string 0, 1, which works most of the time. Regrettably not all of the time, as we're about to find out, but yeah. Okay, the operator precedence. It's pretty much, as we said, left to right, except for when you've got, oh, that's not quite. I think those caret symbols are supposed to be on the same line. Sorry about that. I was meant to try to show that when you've got 2 exponentiations together, it's right to left, not left to right. So, for example, that bottom one there, you would think it'd be x to the power y to the power z, but it's not. It's actually y to the power z first, and then you raise, oh, that's the power you raise x to. You know what I mean? Okay, so it's a little gotcha there. Yeah, if it makes it's not left to right, which you think it will be because you say they're equivalent operators. Why isn't it left to right? Because every other operator is left to right if they're equivalent, and that one isn't. So that's a little gotcha. So yeah, that doesn't quite work the way we think. Anyway, I was going to show you something about type coercion, which I think is probably more relevant to. Oh, there's some strings. Yay. And all you need to know is you can use double brackets to do some strings if you want to. Again, once you know what that is, it's no big deal. And we can see we can use different quotes to do different, put quotes inside, literal quotes inside a string value. Oh, okay, clunk. You can do that too. What I wanted to show you was this. So this is using some type coercion, which is interesting. So look at the first one. It says, okay, string 10 plus 1. So that calculates that as 11. So it figures out that, well, the second operand is a number. The first one isn't, though. And the thing you're trying to do is you're trying to use an addition operator, concatenation operator that works on numbers. So what it does is it type coerces the 10 to be a numeral 10 and makes 11. Sort of makes sense. I'll skip over the second one for a moment. The third one, okay, so like we said before, you've got two values, and the operator is a string concatenation operator, so it decides that it's a string. Yeah, and the same with the bottom one, the fourth one. It says it's a string. First operator is a string, operand is a string. The operator is a string concatenation operator, so it coerces the one to be a string and builds a string, which is not what JavaScript does, by the way. JavaScript does something really, really weird there. I might show you that later on just for a bit of fun.
So you had a variable and you concatenated 10 and 20, but you put a variable name instead of a printers and say equals 10 and 20, it's going to end up with a string.
You would. You would have to. You would hope that the variable, so if you said numeric, the variable would have to be a string at the end of it. Otherwise it would be weird.
Can you cast it back?
Yeah, you can. You can do type coercion, which is good. The second one's a bit weird to me because you say, well, hang on a minute. So it knows that the first operator is a string, and it knows that the operation is not a string operator, but the second operand, is numeric. So what does it do with that? I suppose it's correct. I mean, the first one you can say, oh, it's not a problem because it can work. It can convert the 10 string to be a 10 number. And since the operator is a numeric operator, it works. But why doesn't it take the second one and say, I know the first operand's a string, why don't I make it hello 1 like the other one? You can't add a string. Yeah, you can't add a string, I suppose. But it did the first time. because it did the type question and said, oh yeah, this sort of makes sense, I suppose, and says, but I mean, it could have gone a step further and said, I know the first operand's a string, just make it hello one like the other one. But it's forcing it and saying, no, the operator is a numeric operator. If I can't force both operands to be numbers, we're not doing this. So I suppose that's legitimate in that sense. What else? Conventional escape sequences, as you'd expect, for the usual sorts of things that you might need to do to actually put special characters in strings. Actually, I did what I mentioned briefly is, well, that's just showing that it actually works, so no big deal there. But this thing, so you use the hash symbol to do the length, and you do it for two reasons. One, for length of a string, which is useful, or sometimes length in a number of elements in the table. And we're going to cover that next week, and that's why that can be a problem if you've got a table with elements missing. You won't calculate things properly under certain circumstances when you really want it to. So we might actually do that live next week. I've got a minute and show you that actually works. Comments we mentioned already, but you can do double hyphen, and you can do multi-line block comments like so, and that's sometimes useful, except when you forgot that you did that and your code isn't working. So yeah, and there's a bit of a kludgy thing you can do with stuff like that to sort of deactivate blocks of code, which is sometimes useful for printing things out if you want to use that style of finding out what's wrong with your program. Not that you need to do that, because with test-driven development, your unit tests will show you everything you need to know, right? Yeah. So that won't be a problem for you guys. Depends on the environment you're in, though. So sometimes that could be useful just to drop things onto a console, depending on what's going on in your program. If you really can't figure it out, it can be a useful thing.